Thank you, Paul. Paul just made a very critical point in his penultimate slide, which is that traceability systems do not guarantee the quality of the food inside the packaging. That means that when you have sophisticated counterfeit products like you just saw with the vodka, and also there's a process of refilling genuine containers with counterfeit product, which is a byproduct of our recycling culture. In fact, isoscapes, however, give us an opportunity to unlock the information which is hidden inside the food itself. And so we can use these systems to actually find out information about where a food was produced and its geographical conditions, its climate, its microenvironment, and the geology where the food was produced. So why do we need to verify the geographical origin of food? Well, there are many social and regulatory drivers for doing that. There's a lot of legislation. We have hundreds of foods now which are actually registered as protected designation of origin and protected geographical indication. These include products like Parma and Serrano ham, Grana Padano, Parmigiano Reggiano cheese, Camembert from Normandy, Scottish beef, Scottish salmon, and so on. There's a very long list of very special foods with very characteristic regional and national qualities that consumers prefer, which we need to verify. There's also specific legislation relating to beef, which came out of the BSE crisis. So the legislation which provides consumers with clear and concise information so that they can make an informed choice about the food which they purchase. And of course, all of that legislation about origin has just recently been voted on in the European Parliament in July and has now been extended to a whole range of other products. And on the social side, we have consumer awareness, consumer confidence. We've already mentioned some of these things today. Patriotism, preference by consumers to purchase locally produced food because they're concerned about food miles, or just because they're concerned about animal welfare and so on. So what has been done in Framework 6? Well, we, within the TRACE project, we worked on 21 model test sites around Europe, and we gathered over 12,000 samples of groundwater, soil and food and analysed those. We analysed the isotopic composition of those so that we could build this model, this relationship between the environment and the food that we eat, so that we can unlock these hidden parameters which are inside the food to tell us where it's actually produced. And then we went on to produce these geomodels, or climatic models, that relate climate, geology to the food itself. So how it works? Well, we can understand the link between our food and the environment, where it is produced. We have to take a leaf out of the ecologist book, because they've been using this technology for many, many years to understand the relationships in food webs and also in food chains. Essentially, what we do is we look at the elements of life, the bioelements, hydrogen and oxygen, carbon, nitrogen, sulfur, which make up the foods that we eat, the carbohydrate, the protein, and the fats that we consume. And these are related to various different factors in the environment, such as photosynthesis, sea spray, the use of fertilizers, and also the geology, looking at some of the heavy elements as well, and the metabolism of the animal. So all of these things, if we can understand them and work out the relationship, we can unlock this information that's within the food that tells us where it's produced. So if we use water in wine as an example, the water has these two slightly different forms, a heavy form and a lighter form, called isotopomers. And by isotope analysis, we can look at the systematic variations that exist across the globe. Sorry, the animation has changed since yesterday when I ran through this. Essentially, what I wanted to show you was that water, even through simple processes in the water cycle, undergoes evaporation and precipitation. And going through the water cycle, the water picks up a characteristic fingerprint to show us where it's been. And this characteristic fingerprint has a systematic variation around the globe. And what it allows us to do is determine within certain specifications the origin of the water that's present in wine and in mineral water bottles and so on. And this ultimately to this systematic variation we see here, with differences between the equator and northern and southern regions, and also on continental scales as well. So now I'm going to attempt to do show you a tool which we've developed and which is available for industry to use. It's called an isoscape model, and this tool actually can be used by industry to pinpoint the origin of products. And it's possible to download it and use it and interrogate it yourself. So as you can see here, we have the web portal. This is actually in combination with Google Earth, which many of you have probably used to look up your holiday destinations and so on, but it can also be used to interrogate the origin of food. So, for example, if I put in some characteristics for hydrogen, what we should hopefully see is that the tool provides some potential locations when we just use one parameter from the water. That's a hydrogen isotope composition. If we then add the oxygen isotope composition as well, so we put in some typical values for northern Italy, then take us down to a smaller number of areas, and then finally, if I add the values for strontium as well, zoomed in, and it's not really behaving itself today. But essentially what it can do is it can reduce the number of points down dramatically from a large area to a minimum number of points for the origin of a product. And what we can also do is we can use a lookup table so that we can actually come up with a set of parameters for a product as well for a given location. So for an area near Paris, it gives a range of values for the hydrogen isotope composition, oxygen 18 and strontium that you would expect for a genuine mineral water for that area, so that you can use it to verify the contents of your bottle. Okay. So I'll move back to the presentation now. Okay, right. So that was just in case things didn't go so well. So here we have the actual uptake of this technology that we're getting across Europe now. Grana Padano cheese, which is a PDO cheese, already has the isotope information written into its regulation, so it's already started to happen. That description contains this kind of information. It's also happening for Parmigiano Reggiano and a number of producers in Argentina as well, and in the UK and in Ireland it's being taken up by the beef and pork industries. So this technology is already moving into industry to be used to control the origin of the food, as it acts as an independent verification of the information that we get from traceability systems. Okay, thank you. I'll hand over to Jan now.